Hi students, today's lecture is about nomenclature, particularly nomenclature of alkanes. The names and formulas of compounds are essential vocabulary in chemistry, and the system used in naming substances is called chemical nomenclature. It comes from the Latin words nomen or name and calare, which means to call. So your chemical nomenclature is the system in naming substances. Okay. As of this time, a formal systematic rule exists in generating names for organic compounds. Each rule is formulated and is being updated periodically by the International Union of Pure and Applied Chemistry, or the IUPAC. So the advantage of the IUPAC naming system is that it assigns each compound a name that not only identifies it but also enables its structural formula to be drawn. So previously we've noted about the existence of both continuous chain alkanes and branched chain alkanes, with the former being the simpler type of compound from a structural viewpoint. So the IUPAC names for the first 10 continuous chain alkanes are given in this table. So you have methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, and decane. So note that all of these names end in ane or ane, the characteristic ending for all alkane names. So note also that beginning with the 5-carbon alkane, Greek numerical prefixes are used to denote the actual number of carbon atoms in the continuous chain. So you have pent, so for 5 carbon atoms, you have hex for 6, so on so forth. The key to naming branched chain alkanes is knowing the name of the branch or branches that are attached to the main carbon chain. So these branches are formally called substituents. Okay, so when you say a substituent, this refers to an atom or group of atoms attached to a chain or ring of carbon atoms. So you have to take note that substituent is a general term that applies to carbon chain attachments in all organic molecules, so not just for alkanes. For branch chain alkanes, the substituents are specifically called alkyl groups. So an alkyl group is the group of atoms that would be obtained by removing a hydrogen atom from an alkane. So the two most commonly encountered alkyl groups are the two simplest. So you have the methyl and the ethyl groups. Okay, so in these formulas, the squiggle on the left denotes the point of attachment to the carbon chain. So you have to take note that alkyl groups do not lead a stable, independent existence. So that is, they are not molecules. They are always found attached to another entity, so usually a carbon chain. Alkyl groups are named by taking the stem of the name of the alkane that contains the same number of carbon atoms and adding the ending YL. So, for example, you have methyl and ethyl. Okay, so shown here are the names of the first 6 continuous chain alkyl groups. So you have methyl, ethyl, propyl, butyl, pentyl, and hexyl. So for the formal IUPAC rules and naming alkanes, so we have rule number 1. The first thing that you should do is to identify the longest continuous carbon chain. So we call this as the parent chain, so which may or may not be shown in a straight line, and name the chain after. So for example, this one, so the parent chain name is pentane, so because it has 5 carbon atoms. For this example, the parent chain name is hexane, so because it has 6 carbon atoms. For rule number 1, we have additional guidelines. So it says that if two different carbon chains in a molecule have the same largest number of carbon atoms, so you have to select as the parent chain the one with the larger number of substituents or the alkyl groups attached to the chain. Okay? So rule number 2, for the IUPAC rules in naming alkanes. So number the carbon atoms in the parent chain from the end of the chain nearest a substituent or the alkyl group. For example, this one, so the numbering would be from right to left. So from right to left because the alkyl group is attached to carbon number 2. Okay, so that is nearest the substituent. Okay, for this example, the numbering would be from left to right. Left to right, so that carbon number 3 would have the substituent, okay, the methyl group. We also have additional guideline for rule number 2. So number 1, if both ends of the chain have a substituent the same distance in, so for example they are equidistant, number from the end closest to the second encountered substituent. So additional guidelines is that if there are substituents equidistant from each end of the chain and there is no third substituent to use as the tiebreaker, so begin numbering at the end nearest the substituent that has alphabetical priority. That is, the substituent whose name occurs first in the alphabet. So later on when we will have our example, you will encounter this rule. Okay. So for rule number 3, if only one alkyl group is present, so you have to name and locate it by number and prefix the number and name to that of the parent carbon chain. Okay, for example, this one, so you have 5 carbon, 5 carbons is the parent chain, so that would be pentane. So the substituent is attached to carbon number 2, so that is why its name would be 2-methyl pentane. So you have to locate it by number and prefix the number and name to that of the parent chain. Okay, so for instance this one, another example is this one. So if you have hexane as the parent chain, because it has 6 carbons, so in carbon number 3 you have a methyl group, so the name of this alkane would be 3-methyl hexane. Okay, for rule number 4, if 2 or more of the same kind of alkyl group or groups are present in a molecule, so we need to indicate the number with a Greek numerical prefix, that is, we will use di, tri, tetra, penta, and so forth. In addition, a number specifying the location of each identical group must be included. So this position numbers separated by commas precede the numerical prefix. So we need to the numbers would be separated from words by hyphens. So for example, this one, so In carbon number 2 and 4, you have substituents, a methyl substituent. So the name would be 2,4-dimethylpentene, as you have 5 carbons for the parent chain. Note that the numerical prefix di must always be accompanied by two numbers. So in this case, you have carbons 2 and 4. Okay, and try by 3 and so on. So even if the same number is written twice, as in 3,3 dimethylpentane. Okay, so for example, this one. So in carbon number 3, there are two similar substituents or two same substituents, so the methyl group. So you can mention it twice, meaning 3, 3. So since you have two methyl substituents, so dimethyl, and since you have 5 carbons as the parent chain, so the parent chain would be pentene. So your name now would be 3,3-dimethylpentane. So we have the last two rules in naming your alkanes. Rule number 5 would be when two kinds of alkyl groups are present on the same carbon chain, so you have to number each group separately and list the names of the alkyl groups in alphabetical order. So we have to take note that ethyl is named first in accordance with the alphabetical rule. So carbon number 3, you have an ethyl substituent. That is why you have 3-ethyl, 2-methylpentane. So your parent chain would be pentane. So since you have, because you have 5 carbon chain. Okay. Another example. So if you have this one, so your parent chain would be octane. And in carbon number 3, you have an ethyl substituent. So 3-ethyl. Carbons 4 and 5, you have the same substituents, which is propyl. So 4,5-dipropyl octane. Okay. The last rule would be to follow the IUPAC punctuation rules, which include the following. Number 1, separate numbers from each other by commas. 2, separate numbers from letters by hyphens. And number 3, do not add a hyphen or a space between the last named substituent and the name of the parent alkane that follows. Okay, like for instance this one. So separate numbers from each other by commas. So 2 and 3. So they are separated with a comma. So you have separate numbers from letters by hyphens. Okay, so in this case, 4 hyphen separate numbers from each words. Okay, take a look at that one. Okay. Okay, so let's try this one. So if you are given this alkane, so the first thing that you need to do is to identify the longest chain or the parent chain. So in this case, you can number this alkane from right to left. So if we have here carbon number 1, 2, 3, 4, and 5. So your parent chain would be a pentane. And if you notice, in carbon number 2, you have a methyl substituent. Also in carbon number 3, so you have 2, 3 dimethyl. So your name now would be 2,3-dimethylpentane. Okay, so let's try another example. So if you are given this kind of alkane and you are asked to name this one, so you have to follow again the same rule. The first is to look for the longest chain or the parent chain. So in this case, we could number this from here. So 1, 2, 5, 6, 7, 8. So there are 8 carbon atoms in the longest chain. So the parent name would be octane. And there are 3 alkyl groups present. So you have ethyl and you have 2 methyl substituents. So thus you have dimethyl. Okay? Selection of the numbering system to be used cannot be made based on the first encountered alkyl group rule because an alkyl group is equidistant from each end of the chain, I mean. So thus the second encountered alkyl group is used as the tiebreaker. So it is closer to the right end of the parent chain, which is carbon number 4. So your ethyl substituent is connected to carbon number 4 or is attached to carbon number 4. So it is nearer or closer to the right end of the parent chain than to the left end, which is carbon number 5. So thus we use the right to left numbering system. Okay? So two different kinds of alkyl groups are present. You have ethyl and you have methyl. Okay? Ethyl has an alphabetical priority over methyl and precedes methyl in the IUPAC name. So the IUPAC name for this one would be 4-ethyl 2,7-dimethyl octane. Okay?